Assalamualaikum and hi, my name is Najihah Shafiee. In this video, I'm going to present my industrial training journey at UiTM MTC Hamburg for 15 weeks. UiTM MTC High Energy Material Research Laboratory or Hamburg is the collaboration between NPC Engineering, Sdn Bhd and UiTM to develop local technology in rocket propulsion as baseline of long-term objective. This team consists of people with different backgrounds, each with their own expertise, area and strength. This team successfully combined PhD level academic background with industry-related expertise. For the vision of this company is to develop local technology in government of Malaysia strategy, assets acquisition and local solution for defense industry. And for the mission is to optimizing local talent in providing and total solution for defense and aerospace industry. This slide shows organization chart of Hamburg. For the head of Hamburg, it handled by Prof. Madya TS Dr. Zuraida binti Saleh. Meanwhile, head of MTC Defence is Lieutenant Colonel Tuan Muhammad Juani. The purpose of the industrial training is to expose students to the real work environment and gain knowledge through hands-on observation and job education. The exposure to the industrial environment will trigger students to apply the theoretical knowledge learned in lectures and improve their practical skills. And this will motivate students to practice the right working attitude and professionalism to increase the employability potential. For the scope of training, students can gain beneficial and practical knowledge and fresh idea about the working technique. And the project and tasks that had given will focus on fabrication rocket body including fins and nose cone using fiberglass. The objective of product is to introduce new superior material which is fiberglass as another initiative to fabricate the rocket body instead filament binding and to analyze the capabilities of fiberglass reinforced epoxy. For this project, hand layup process had been used. Hand layup is a manufacturing process that involves manually laying down individual layers of plies of a type of reinforcement known as prepreg. The layup process entails shaping each ply by hand and then firmly adhering it to the previous layer or mold surface, leaving no air pocket between plies. We proceed to the process of fiberglass fins. First and foremost, the fiberglass was cut following the mold size which is 21 cm and 25 cm. The epoxy A and epoxy B were weighed which is 150 gram A and 45 gram B according to 130 ratio and both of epoxy mix. Before putting the mixer epoxy, the plastic and mold was wet first to prevent epoxy attached to the mold and easy to remove mold after hand layup process dry. After it dried, the first layer of fiberglass was put on the mold and the epoxy was sprayed and the bubbles discharged. Then another layer of epoxy was sprayed and a layer of glass cloth were put layer by layer until it reached the desired thickness which is 4 mm. After that, the mold was put under hydraulic for 24 hours. Before we make the fiberglass nose cone, we must make the mold first. For the first step, the board was cut according to the size of the nose cone prototype, then followed by fitting the nose cone into half of the parting board. After that, the gap between board and nose cone prototype was filled with the clay. The wax and PVA release agent were put on the board and prototype nose cone. This PVA is a traditional mold release agent and can be wiped on or sprayed onto the wide range of pattern and mold surface to provide a very compatible and reliable release barrier for epoxy composite. Next, the 4 pieces of fiberglass was cut into the 4 parts and the first layer of the fiberglass was put on the top of the nose cone prototype and board. After that, epoxy was sprayed carefully and bubbles was removed. The half nose cone was left for 24 hours. After 24 hours, the half mold was taken out from the nose cone from the board. The adhesive board on the mold was cleaned using paper. Another half of the nose cone was made following the similar method and left it for 24 hours. The mold of the nose cone was drilled to make holes for the screw installation, spread both sides of mold. The wax and PVA were put all over the mold. The 4 pieces of fiberglass were put layer by layer according to the mold shape with epoxy into it. The nose cone was dried for 24 hours. The excessive fiberglass around the edge of the nose cone mold were trimmed. Next slide, we each show the production of nose cones. The wax and PVA were put all over the mold first, and then the 4 pieces of fiberglass were put layer by layer according to the mold shape with the epoxy into it. The nose cone was dried for 24 hours. The excessive fiberglass around the edge of the nose cone mold were trimmed. The 39-gram mixture of epoxy and fiberglass was put on the edge of the mold. Then both sides of nose cone were attached together and clamped for 24 hours. After 24 hours, the nose cone was taken out from the mold and the nose cone was cleaned by using sandpaper. The epoxy was sprayed on the nose cone by using a brush for smooth finishing. The nose cone was done. Impact that I get from industrial training is teamwork, communication skills, and gain new skills. In this process, the trainee should work in team to complete the product. This teamwork will help trainee to communicate well with the team, and this will improve communication skills among the students. Due to PKP, I only learn about hand layout process by watching the YouTube. Hence, during this industrial training, I get the opportunity to gain new skills for the hand layout process. For the conclusion, students are exposed to the real working environment where it is an efficient method in producing a well-rounded graduate. The environment in industry is different compared to studying in the university. The variety of jobs help the students to give wider perspective of the reality of working in the industry.